Welcome to Cosmos DB Conf and my talk, 7 years of experiences from Cosmos DB. My name is Sakari Nahi. I'm the CEO of this company, Azure, that was founded 10 years back, and we purely work on Azure. I'm also a Microsoft Regional Director and an Azure MVP. Also, there's this meetup user group in Finland Azure user group, and we do pretty mean stuff on YouTube on Azure. So if you're not familiar with us, you can join us and see our channel and see if there's something you'd like to learn about. Azure is a company that looks for challenges and likes to grow by solving them. Sometimes the first time we don't succeed, but the next time we learn and then we get better. And it seems to fit some experts' mind space to work like this. To talk. It was August 2014 when DocumentDB was released to public preview. And with the people, with the experts, with some developers, we were working on this project, and we kind of got excited. We felt it would be a good fit for the project, and we started working on it. Half a year later, in March 2015, we were able to deploy the application with DocumentDB, and we were pretty happy. It was working very well. We put all of the entities in the application into a single container. In those times, the pricing was based, if I remember correctly, it was based on the number of containers, on the amount of containers. So we were like, okay, let's make this cost efficient and put everything in one. It's easy, it's NoSQL, it's schemaless. Why not? The next month came and DocumentDB became generally available. And what happened was that the pricing changed from container amount based into request unit based. That was a bit of a bummer. I remember the moment when the pricing on that thing jumped from 100 euros to 4,000 euros or something a month, and the client wasn't too happy. So we kind of had to refactor the solution, and the fastest way we knew, we ported everything into Azure SQL. And that wasn't too auspicious. That was the beginning of my experiences with DocumentDB, today Cosmos DB. However, since then, I've been working with Cosmos DB for the last 7 years. And nowadays, what I do mostly is I assess and optimize solutions that for some reason need more performance or need to cut down on costs or something like that. So today, we will go through some of the most common things I see when I visit teams and visit customers on what's wrong or what could be optimized on their Cosmos DB deployment or environment. I've never done this. So I thought I'd begin with the summary. Now, if you are very, 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 very busy, like we might be today when it's the COVID time, so there's a Teams meeting starting every second, you can just watch this summary, and if you don't want to see anything else, then we're kind of done. These are the 14 things that I'll walk through quite speedily. This talk is not aimed at total beginners. So if you are a beginner at Cosmos DB and you don't have the basics down, then you might have to stop every now and then and check out the Microsoft Docs. But I'm pretty sure that you can still follow and get the gist of it. If there's nobody interested in any of the parts, then I think I'm done. But if you'd be happy to know something more, let's get on. Now, this isn't really a tip on your environment. The first one is something I've been feeling for the last couple of years, and it relates to the naming of the Cosmos SQL API. If you look at the creation picture on the right, there's the API is called core, and in parentheses, there's SQL. And that is something I think that the product group is moving towards. They are trying to fade the SQL naming, but it's kind of impossible because the SQL language is there and it supports joins, and there are these quite nifty capabilities that can be used very effectively. But at the same time, it really, really can hinder the development. Now, if you are part of a team who's never done Cosmos DB, or you've done but your mates haven't, please, the first thing you have to do when you are starting a project on Cosmos DB, tell your friends that it is not SQL. Actually, if you can, just tell your buddies to go through some of the basics of Cosmos DB. The Microsoft Docs are very good, and it will take a good developer like an hour or a couple of hours of reading through the materials on these things I've listed, which I think give out a good base on understanding the Cosmos. The provisioning of throughput. Is it database based or container specific? Are you gonna provision the throughput manually or with Autoscale? The partitioning strategies, they are key. You need to decide those in the beginning of the project. So it makes good sense to learn something about the partitioning keys, the way the physical partitions act behind the scenes, because you have no control over those. Then there's the harm caused by cross-partitioning queries. The cost of SQL API, when should you use it and when you shouldn't? When should you read directly? That is surprisingly often. Co-location of entities, which is something SQL people would never do. They don't co-locate entities in a single table. Tables have a schema. And then indexing, somehow often forgotten fruit. So with a team, go through this list and think about those. Have a bit of a brainstorm, a little bit of a chat, and I guarantee that people will start realizing that, okay, this is not your grandma SQL we are working on. Sorry for having a sip. It's quite late in Finland. So, diagnostics. Again, not a performance optimizing tip directly, but something that's very weird. Now, I've been looking at some environments that are, pretty nicely sized, like hundreds of millions of items getting tens of millions of items in a burst daily, and equal amount of queries in a peak usage in unpredictable usages. And then I go check, hey, how could this be optimized? And the diagnostics are off. They are always off. So if you are using Cosmos DB, if your environment has Cosmos DB, go check it out. I bet you a dinner, 80% chance there's no diagnostics on. If the diagnostics are on, groovy. If they're not on, and you are using SQL API, which is something a lot of people use, turn on data plane requests. Now, if you're using Mongo, Cassandra, Gremlin, there are other requests ending diagnostics you can turn on. Also, partition key RU consumption might be interesting, but I think it currently only works with SQL API. So, as you know, Cosmos DB goes forward at a rapid clip, and the product group is always producing something new. So I think that might be something that might work with some other ways at some point, maybe, or something similar. But for now, it's only with SQL API for sure. Go check out the link on the diagnostic settings basics and turn those on if you feel they're necessary. Next bit is again something that feels like a controversial thought. Like if you've been developing for 20 years, like I have, then it's not a thought you had earlier. You were developing an app, so like some kind of a web app or something on top of a SQL, and you weren't like, okay, let's hope for rate limiting. Let's use the SQL until it can't respond anymore. That was a picture of horror. That was a nightmare. With Cosmos DB, however, you should kind of aim for rate limiting. That should be the first thing. Hey, let's optimize the costs so that it rate limits a little bit. You should be getting some 429s. Now, if you don't get 429s and you are using manually provisioned throughputs or you are using Autoscale, in either case, it might mean that you are paying too much. It doesn't necessarily mean maybe you're just so optimized. Maybe it's, down the line, but it's very good to check that. If you don't get 429s, then that might be a sign of overpaying. In some applications, 429s cannot be accepted, but in many cases, let's say you have a business application, like 95% of the applications, and there's a person who's using the website, and they don't get the website rendered in 0.8 seconds, they get it in 0.9 seconds because of Cosmos DB 100 millisecond retry. So that often isn't an issue, and the rate limiting can really, really help. What you get, if there's a 429, you get the information on when you can retry, and most often you don't have to worry about that because the native SDKs, the .NET SDKs, Java, Node.js, Python, and so forth, they catch the response, they check the response, and then they retry again, and you can configure that approach. So aim for rate limiting, explicitly decide you don't want to aim for rate limiting if your application is strategic enough. Next one is something that is again a bit surprising. Indexing is something that's very visible in Cosmos DB. There's a lot of talk about indexing in the docs. They are very visible. But in many cases, when you need to optimize something, they haven't been untouched. It might be, hey, could you optimize the writing? We don't get the items here fast enough, and it's causing some bottlenecks in the process down the line, and then it indexes all properties. So optimize indexing, check out your indexes, remove properties you do not query with, the application doesn't make queries with, so the writing is a lot faster. If you do bulk inserting or importing during the night, for example, from 2 a.m. to 3 a.m. or whatnot, then it might make sense to consider setting the indexing to none for that time. Now, in some cases, you want to have the data fully indexed when they are in there, but in some cases, you just want to have the data there. You maybe want to let other consumers or databases fetch the data with IDs or whatnot so that they exist in Cosmos DB, and then you can index them leisurely if you are not getting complex queries at that time. And then, of course, if your order by clauses are slow, then use composite indexing. That's gonna help. Provisioned and scheduled throughput. This is something that actually is one of the highest cost savings available, or that's how it feels to me. Here you see the picture on the right, I guess, from your viewpoint. I don't know if this is mirrored or not. And one of the highest cost savings available is that here you have the 600K request unit per second maximum usage, and it's for half a day or 10 hours or 8 hours or something, and then it's lowered into 120K. So that's quite a hefty lowering of the request units per second throughput. And that's done by scheduling the throughput with Azure Functions. So look at that. If you have predictable workload, it means you can schedule it. And then just set up the Azure function to do it in a serverless manner. You don't have to pay a lot for that. And that can really save you a lot of dough. If your throughput is not something you can predict, now predictable throughput and scheduled manual provisioning of throughput, that's the cheapest way to do Cosmos DB in a sense. Now, if you cannot predict the throughput, then Autoscale is a great option. And it's really a bit like magic. It's very exciting and it feels very elegant. And for a developer, it feels very nifty because it just works so fast. You see there's a need in your database and you have set it at 4,000 request units. So it goes between 400 and 4,000 then, and it very fast scales into what you need. But it does scale a little bit greedily, or at least that's how I feel about it. If there's even a slightest bit of chance that somebody might need a bit of request units, a consumer or a query, then Autoscale will jump very fast, very high. And that, of course, means that there are no 429s when you do Autoscale. Scales between n and 10% of n. What's noticeable with Autoscale? Otherwise, it sounds like a dream, but it is 50% more expensive than the manual scaling. So it turns to loss after 15 hours of maximum usage, and the rest of the day or night should be used on the minimum, on the 10% scaling, and otherwise it's going to be the same price and more expensive than manual provisioning of throughput. So think about that. If you have unpredictable workload for, let's say, workday in your time zone, like 8 hours, or from 6 to 6, 12 hours, and then your database really settles down for the 12 hours, like there's not really any usage, some late workers maybe or something, then Autoscale is very nifty because it works as intended, it's more cost effective, it gives great performance, and there's no worries. However, what's cool is that you can also schedule autoscale. So you can schedule a higher autoscale range and then schedule a lower autoscale range later. This might run into trouble with physical partitions and how they will be spread out. And we will speak about physical partition growth later. So you can see it then. I urge you to look at this feature. It can be pretty handy in some situations as long as you get the boundaries. Large items. Now, 1 kilobyte items are optimal. It's very good to somehow internalize. It's very good to internalize that if you go large, if you have larger items, a lot larger items in Cosmos DB, you're gonna run into issues that are very bothersome. 100 kilobyte items result in 10 times the request unit cost. But of course, if you did 100 times 1 kilobyte items, that would be even more costly. So in some cases, it does make sense to use a little bit bigger items. Max item size is 2 megabytes. So Cosmos DB isn't for really large files. And if the files go nearer to that, then I would consider using something like Azure Storage as the storage for those documents, and then just reference to them from Cosmos DB. This is something that is good to take into account. We're going to talk about on storing entities later, and I will give you some hints on this. Reading with SQL API. There you have a document that I generated with some web app somewhere. And it generated me this document. It's pretty okay business document, not a lot of properties, but some properties. And if you go to Azure portal and you do a fetch on this kind of a document with the SQL clause, then you get these kind of results. You see, okay, these 700 bytes, it's less than 1 kilobyte. That's good to understand. You could add some more data into a document like that, and it would still be the minimal optimized, the most optimized document size for Cosmos DB. But the request charge shows you the cost of that query, and it's 2.9 request units. And as you may know, what Cosmos DB says, what the documentation says, the cost of items, the request unit cost is defined by 1 kilobyte item being read from Cosmos DB. That should be 1 request unit, and this is 2.9. So what's going on here? If we look at this from the code perspective, the box at the top is reading directly. So there we have the ID and partition key, and we read from the C# snippet with read item async function. We give it the ID and the partition key, and we get the document back. At the bottom, we have the reading with SQL, that we do the same kind of SQL sentence we did in the previous slide, and we get the same document back. What's the end result with the request unit cost is now there at the below. So the direct read cost 1 request unit, and the SQL API read cost 2.9. So if you are working and you are able to optimize the size of your documents to 1 kilobyte, you know that you can do direct reads with 1. But if you do it with the SQL API, that's going to be thrice the cost. That's quite a heavy difference. Now, if instead you have 1 megabyte documents in Cosmos DB and you spend like, I don't know, 100 or 1,000 request units to read that 1 megabyte document somehow with a direct read, then the SQL additional cost for the SQL API engine to spin up, which is the difference between 1 and 2.9, is not as meaningful. So the SQL API can be used in a more relaxed manner when your items are bigger. But if you really want to optimize your Cosmos DB, you use small items, and then you have to be careful when you spin up the SQL API engine. And I think this is pretty interesting. The cost is 1.9 when you spin it up, or something like that. All right, about physical partition growth. So this is what I referred to earlier. Now we have a single physical partition here, and it contains a number of logical partitions. And the logical partitions, of course, are by the partition key. Now you've set up 10,000 request units per second throughput to the container, and I'm not sure, maybe at 10,000 directly, because that is the maximum limit a physical partition can handle. So if I put 10,000, maybe Cosmos DB spins up 2 physical partitions, so there's some space or not. I'm not sure about that one, but let's assume there's 1 physical partition. It can give data back at the rate of 10,000 request units per second, and it can contain 50 gigabytes of data. As an aside, a single logical partition can contain 20 gigabytes of data. Whenever you design your partition keys, you should never go near 20 gigabytes. But let's see. So this is the kind of thinking that there are physical partitions behind those logical partitions, and you have no way of controlling how many physical partitions you get. So it's very important to understand and being able to envision the amount of physical partitions depending on how much you have data and how much you utilize request units. So a little bit more complex example is that your application above now gets a huge load of users. It's Black Friday and you work in retail. And you peak at 300,000 request units per second for that Friday, your database, so that Cosmos DB can really handle the load. And it can handle the load brilliantly. So it's just going to scale the physical partitions. The logical partitions are distributed in those. Hopefully you did the partitioning strategy correct, so there are no wrong hot paths and so forth. And then you get 10,000 request units per second out of all of those physical partitions. So that's kind of like perfect scaling, at least in this picture, because earlier you had 1 physical partition, then you have 30, but the throughput from every physical partition is as good as from the first single physical partition. Now let's assume that this busy hour has passed, the busy season has passed, and you're like, all right, 300,000 request units per second, that's mighty expensive. Let's lower the amount of throughput and get some money back. You lower it to 30,000 request units per second. And what happens is that since you have 30 physical partitions, they all get 1,000 request unit per second cap. And this might become a surprise to you. Earlier, when you had the peak and there were some items in a physical partition that were fetched with a throughput of 10,000 request units per second, maybe there are some very costly queries, or maybe there's a lot of data coming out, or whatever, or maybe there are just that many requests going in, and suddenly you have the same physical partition that will have less load because the busy season has passed. But if there's a hot path, you get throttled and rate limited at 1,000 request units per second. And that has bit some teams in the bum. To my knowledge, there's no way for us developers to merge physical partitions back. Now, in this scenario, I would like to roll down the amount of physical partitions from 30 to 3, but that's not possible yet. I'm pretty sure it's gonna be possible, and this is of course not something you run into on the first day when you're using Cosmos DB, but if you are planning your queries to the amount of 10,000 request units per second, which is the maximum for a single physical partition, and you scale horizontally and then you scale down, then you'll see that this will happen. And this is nasty in the sense that usually this is something that's noticed during when the application is in production. This is not something people anticipate when they do the design and they're like, okay, this works. And then there's new users and they scale it and they're like, okay, this still works. It's amazing. And then they scale down and they start thinking that, hey, how come these same queries or performance is now slower than it was even before we scaled up? This can be the reason. So be aware. Next one is general stuff on storing entities. First, about co-locating entities. That's something that's very against SQL. kind of thinking. If you are and like many developers are, especially the people who've been developing for 20, 15 years or so, they didn't start with NoSQL databases. They started with SQL and ACID and normalization and relationships and stuff. And now suddenly you have these SQL-like capabilities in Cosmos DB, and then you should maybe think about co-locating entities in the same table, in the same container. Now, if you have an application and you need to fetch a lot of data into a view or into a function in the application, then consider co-locating those entities in the same container. That will optimize and minimize the query scope and can be a very good example of this feature slice kind of approach that you might be having in your backend logic or backend architecture as well in your application. The other option, the other way to approach is to think about whole documents. If your documents aren't getting too big or too large, even if they have some additional information, we've seen it beneficial to store, even if there are duplicate data, to store a document that has some of its relational data stored in that document as well. Then if you have a view, you get the data and you get all data. Of course, there's a bit of a bother about the synchronization and so forth. So some parts of data might grow old. You have to think about that one. But sometimes you don't have to worry about creating this snapshot in time and just storing the whole thing like a cache-like whole document in Cosmos DB. And then the last one that I've been very happy and we've been very successful with is using Azure Cognitive Search with Cosmos DB. So I think those two go together. They're like very good buddies, because if you think of Azure Cognitive Search, if you use it like 100 or 200 euros or dollars a month, and then you put all kinds of stuff there and your client is like, or your boss is like, hey, we need this feature and that feature. And by the way, wouldn't a Google-like search be cool? And stuff like that starts cropping up, and you've been doing well with the Cosmos DB. And then you're like, okay, let's put the Azure Cognitive Search here as well for the searching capabilities. And then you index your items there and you find the items. And when you want more detailed information, you want information that's not part of the search query or the parameters you can do a search for, then the details are in Cosmos DB. What you do though is that you find the ID from the search, and then you fetch the data from Cosmos DB with the direct read that we saw earlier. And this can result in a situation where your Cosmos DB is actually the minimum sized, like 400 request units per second, where you have a bunch of items, like a lot of items, and you can make 400 queries a second into it. That's almost 1.5 million queries in an hour. That's a lot of users, a lot of queries. And you use the search engine up front, and then you just get the files, get the documents with the ID. And that usage, there's often when I speak with teams, they are either that it costs too much, it's performant, but it costs too much, or it's not performant with the price we can pay. But then there are these kind of capabilities of hey, really getting the data out with a cost of nothing, and you can put in 400 requests per second. And I think that's pretty amazing. But that is, of course, something you have to plan from the beginning. On partition keys. So I think I said already, logical container max size is 20 gigs. So if you think that some subset of your data for a certain topic might become close to 20 gigs, don't choose a partition key that would reflect that amount of data. Your partition data should never get close enough to 20 gigs. I think there would be some performance issues with that. So if you think of partition keys and you are struggling with doing the partition key design, and that's something you need to kind of set, not in stone, but close by in the beginning of the project, because as the project grows, it's going to be harder and harder to change the partitioning strategy that you have going. There's good to know that there are a few strategies that do not really work often, and that's like index numbering or random GUIDs. They are stuff that really work with SQL databases, relational databases, but if you do IDs that are like 1, 2, 3, 4, or just random GUIDs, and then you want to get data with a surname or a city, or get me the tasks that are in project XY, then what you are actually doing, you are doing a query that reaches into all of the logical containers and therefore into all physical partitions underneath them. And it's a so-called cross-container query, cross-partition query, I mean. And that is very expensive from the request unit point of view. So you kind of have to forget the index numbering and the random GUIDs from the get-go. Now, the other thing that doesn't really work is that if your application, for example, returns the people in a city, for example, and you have Shanghai, and then you have Helsinki, or then you have even smaller town like Kankaanpää, where I was born in Finland. Then you make a query for people in Shanghai. That's going to be a very different amount of people you get from partition, and then you make a disproportionate strain on the Cosmos DB architecture. And that's not an efficient way of partitioning your data. Strategies that might work, depending on your application. If you have users and you do queries for users and you want data about users and so forth, user ID sounds good, especially if your users are, you make the same amount of queries or they have the same amount of data, or that's close enough. Or tenant ID if they are equalish enough and so forth. And maybe you have one for other and one for the other. Or around some application feature. You have rooms, or then you have reports, or maybe you have some classification or something. You have an ID for those things that are equal from an external point of view when you look at the amount of data and the amount of queries they get. So those kind of strategies are good to think about when you start trying to figure out what are the partition keys I would go for. So avoid cross-partition queries at all costs, and avoid the kind of situation where you know that, hey, 90% of our queries will be headed to partition key Shanghai, because that means that you are just creating a bottleneck to the throughput that will be to a single partition, to a physical partition underneath, like we saw earlier when we spoke about the physical partition growth. So be careful with this. .NET bulk support. If you've been using Cosmos DB for a while, then you might be aware of bulk executor library. So this .NET bulk support is something that came like a year and a half back or something. And a year ago, there was this update to it. It became even more performant. It is basically an implementation that parallelizes the inserting of items for you. So it sends data in batches of 100 items or 2 megabytes, whichever comes up first. And if the batch doesn't fill up, it waits for 100 milliseconds and then it sends it. So this is something that really makes the upload or inserting of data faster if you have to do stuff like that during the silent hours of the night. Look that up. On consistency levels. If you are not very familiar with these, then session is good enough. If you are not kind of sure that, hey, our application is gonna have to play with these, then session might be the right call. It's often very good. What is interesting to note is that if you feel you have to go to stronger consistency levels like bounded staleness or strong, then they will cost you double the request units, because the same operations will be done against 2 replicas. And that's something that's nice to know before you even start to think about it, that you are just doubling your cost. Do you really, really need this? In some cases you do. For basics, there's very good Microsoft documentation on these consistency levels, so go check it out. And even the Azure portal on the consistency level selector, it has a nice demo of nodes. So now let's talk about something called two-container strategy. It's a pretty common scenario. There's incoming data from a lot of some things. In this case, I'm saying devices, and these devices are situated in sites all around the world or something, but there's a lot of data coming in from devices. And you want to bulk insert items. You want to insert items in a batch because there's a lot of incoming data, and maybe they come in burst during the night or during the early hours or something. That's when the devices send their daily load, for example, or something. It's not exactly streaming, but it might be something like that. And then you have a bunch of consumers, maybe applications, other databases even or something that might be interested in the device raw data, but some consumers are interested in the device data by site. If a site has 100 devices, maybe it's a building, it's a smart building, you are reading the warmth or air conditioning data of the rooms or whatnot. So do you optimize writes or reads? And that's kind of a business question. Like, do you want your consumers to be fast, or do you need to have the inserting of data to be fast? And often, of course, the answer is both. Both need to be fast. Now, if you start optimizing for writes, that makes sense because you get the data before you do the reading, and you're like, hey, let's make the writes fast. And you're like, okay, very fast writing of this data would be doing the bulk insert in such a way that the partition key would be any hash, just a generated something. We spoke earlier that GUIDs are bad, and now I'm saying that can be used to write data into Cosmos DB fast. Because if you do the bulk insert does 100 pieces or 2 megabytes, or then it waits for 100 milliseconds and sends the batch that is in there, like 2 or 3 items or something. In this manner, you just get the data, you get the 100 items, and you send those immediately. And that one batch would be then one logical container with some hash, any hash. So the bulk inserter would just batch the files and send them into container, and that would be very fast. However, reading that container would be crazy, excruciatingly slow, because if you query with site, your Cosmos DB has to check in all of the logical containers and therefore all physical partitions for those devices that have the property site for whatever parameter was given in. If you then optimize for reading, then you of course put the partition key site, so all the device data for site is in the same location, and when you read by site, bam, it comes out fast. However, when you are doing inserting of data, you have to, at that end, you get like data from all the devices, and then the bulk inserter tries to select the ones that go to site, and then it gets like four files instead of 100, and then it sends 4 files in a batch or 5 or something. And the parallelization is not 100% of 100 items. Instead, it's like a level of 4 to 5% or something. So you can see the issue. One or the other is non-optimized. Two-container strategy can fix that. This is a real-life production curve of a situation that I just described. In this situation, the customer, the system was getting data from before 5 a.m. and it ended before 6 a.m. and the data was coming in, and there was reading from the container at the same time. And the write took a lot of, they're like peaking at 9 million request units taken in a few minutes or something. So that's a lot of request units and throughput required. And if the situation was such that at the same time the read would be peaking, it is not at that time, but if the read would be peaking, then it would be hard to estimate the amount of air use required at the same time as data is being inserted. So it's very hard to control the kind of approach where one container is the answer for everything. Now, in two container strategy, the key is that there are two containers for both operations. The writing is with hash, for example, because that's fast that way, and reading is fast with the site, as we spoke. So the process would be that the fast bulk insert is done to any hash with the bulk inserter, and then there's a change feed mechanism to trigger Azure function to get the items from the write container and storing those items in the read container, but by the site partition key. So this would mean that there's a fast write and a fast read, and in between there's a bit of a complexity with the change feed and Azure function that kind of orchestrates and organizes this whole thing. What is the benefit of this is that write container throughput can be optimized separately and the read container can be too. If the read container doesn't need a lot of throughput during the night, put that down. If the write container only needs a lot of throughput from 4 a.m. to 6 a.m., you can schedule that down otherwise. And in this way, you can handle the peaks of usage for both containers separately. There's one other point, and it comes from this diagram. And these are again production lines, production diagrams, or telemetry. And above we have the single container, and below we have the two container. And as you can see in the below model, the writing operations are done at something like 5 a.m. and 5:25 or something like that. And that is the point when all the data is in Cosmos DB. In the above single container approach, all the data hasn't been written, or we don't know if it's all been written in the database. And in the below container, or we know it's not written. And in the below approach with two containers, the data is written earlier. And this means from an enterprise architectural viewpoint that the other consumers, other databases, like Synapse, for example, if you are using Synapse Link with Cosmos and you have some kind of analytical store inside Cosmos DB, then you can start enjoying all of those device items written like at 5:30. That is not possible with a single container approach. So this two container approach is sometimes a helpful pattern. To summarize, I've now categorized these tips, I guess, into easy optimizations and slightly harder optimizations. The easy ones are: tell your friends SQL API is not SQL. Turn diagnostics on if you feel like there's something iffy going on. Aim for rate limiting. Don't be afraid of rate limiting. Expect rate limiting. Be happy about rate limiting. Optimize your indexing. Like, don't just forget. It's so easy to optimize it. Like, look at it in the beginning of development. Start playing with it. Schedule your throughput if you can expect and predict the usage. And if you cannot, if it's unpredictable, use Autoscale. Large items are an anti-pattern. The smaller your items, the more optimized you can do your Cosmos DB. And then reading with SQL API, if you can do it with the reading directly, do that, because spinning up the SQL API engine can cost like 200% more, which is surprising, but that's with the very small files. The slightly harder optimizations are harder because they require more code changes into your application or solution, or they require changes into how the files are inserted, or how's the bulk done, or something like that. Physical partition growth is very hard because if you let the amount of your physical partitions grow very high, then it's very hard to merge those back down. On storing entities, if you approach the storing of entities in a SQL mindset, then co-location or storing whole documents where some of the relational data is duplicated, that might be hard to envision. And also sometimes using Azure Cognitive Search makes sense. On partition keys, like if in the beginning the strategy is not sound, then making changes during the project, it's very annoying. It is possible, it's been done, but it just takes a lot of work. Bot support, changes how you insert the data. On consistency levels, if you're not familiar with them, don't play with them, or you can play with them, but be careful because they might cause surprising issues. Your customers or the end users of the application might come back to you and say, hey, what's going on? Like I used the application and I think I'm seeding different data than my mate over there. So be careful with the consistency levels. And the 2-container strategy, that can be something that helps you create a more granular architecture inside Cosmos DB, thereby giving you more control and more capability of defining the throughput by operation. And now I'm done. Thank you, everybody. It was a pleasure to be here and see you somewhere physically, hopefully very soon. Bye.